What if I told you that the universe, this vast, seemingly infinite place filled with billions of galaxies, has no center? It's a question people have asked for as long as we've understood the universe is expanding. If it's getting bigger, there has to be a starting point, right? A middle, a cosmic bullseye where it all began. And yet, the more we study the cosmos, the clearer it becomes. There is no single spot you can call the center of the universe. The expansion is happening everywhere. This isn't just a scientific oddity. It's a complete shift in how we understand space, time, and our place in it. The Big Bang. Misunderstanding. Let's start with the picture most people have in their minds when they hear Big Bang. You probably imagine an enormous explosion, throwing matter outward into empty space, like a firework bursting in the night sky. The sparks shoot out from a single point, and if you rewind the film in your head, all the sparks trace back to that original explosion site. That's the way we think of most explosions. And it's exactly why the Big Bang is so often misunderstood. Because the Big Bang wasn't an explosion in space. It was the expansion of space itself. The raisin bread analogy, to understand this, think about baking a loaf of raisin bread. The raisins represent galaxies, and the dough is the fabric of space. When you put the dough in the oven, it starts to rise. As it expands, the raisins move farther apart. They're not flying through the dough. The dough itself is stretching, carrying the raisins with it. Now here's the key. Where's the center of the bread's expansion? If you're looking only at the dough, there's no special spot inside it where the rising began. Every raisin sees every other raisin moving away. And from any raisin's point of view, it could claim, I'm at the center. That's how our universe behaves. Hubble's astonishing discovery. In 1929, Edwin Hubble made a groundbreaking observation. He found that no matter where he looked in the night sky, distant galaxies were moving away from us. And the farther away they were, the faster they receded. This pattern wasn't random. It was the signature of a universe expanding uniformly in all directions. It also meant something profound. If we could magically teleport to one of those faraway galaxies, we'd see the same thing. Other galaxies rushing away in every direction. From their perspective, they would be the center. From our perspective, we are the center. From the perspective of a galaxy on the far side of the cosmos, they are the center. And that's the point. Everyone is the center. The observable universe trap. Here's where it gets even trickier. The observable universe, the bubble of space we can see, is about 46 billion light-years in every direction. That's not the whole universe. It's just the part that's had time to send light to us since the Big Bang. When we look out into deep space, we're also looking back in time. At the very edge of what we can see is the cosmic microwave background, the leftover glow from when the universe first became transparent, just 380,000 years after it all began. From here, it surrounds us like a perfect sphere. It's tempting to think that means we're at the middle of it all, but that's an illusion. If you could stand on a galaxy 10 billion light-years away, they would see the same perfect sphere of ancient light surrounding them, the same cosmic background, the same illusion of being in the middle. It's not that we're special, it's that the expansion looks the same from every point in the universe. Space itself is stretching. One of the most mind-bending parts of this is that galaxies aren't racing through space like cars on a highway. Instead, the very fabric of space is stretching, and galaxies are simply riding along. On small scales, like within galaxies or between nearby galaxies, gravity holds things together. But on cosmic scales, the stretching of space dominates. Think of dots drawn on the surface of a balloon. As the balloon inflates, the dots move farther apart, not because they're moving themselves, but because the surface is expanding. And just like the balloon's surface has no center on it, our universe has no center in it. No edge, no center, no privileged point. This idea also means there's no edge to the universe. If every point is moving away from every other point, there's no outer wall. You could travel in any direction forever and never hit a border. Space would keep going, and depending on the universe's shape, you might even loop back around without realizing it. It's humbling, because it means we're not sitting at some cosmic command post. We're just another location in an endless expansion. Dark energy and the speeding expansion. If this weren't strange enough, there's another twist. The expansion of the universe is actually speeding up. Something, which we call dark energy, is pushing galaxies apart faster and faster. Billions of years from now, galaxies that are now visible will fade beyond our reach. the night sky will grow emptier. And future civilizations may never know other galaxies existed at all. We live in a special window in cosmic history, one where we can still see the universe's grandeur in all directions. Why this changes everything. Knowing that the universe has no center reshapes our perspective. It's not just a fact about physics. It's a reminder that our point of view isn't the only one. That every galaxy, every civilization, every observer experiences the same truth. From their perspective, they are the middle of it all, and yet no one truly is. It's an elegant, humbling, and beautiful truth, the kind of realization that makes you feel both small and connected to everything. The question, where is the center of the universe, has a deceptively simple answer: everywhere. And that's the beauty of it.